All right, hopefully you can see this okay. This is the original cubic function with your a, b, c, and d. In these your conditions, p of 0 is 0, first derivative of 0 is 0. The function evaluated at L gives you h, so the point LH is on the graph, and the first derivative evaluated at L gives you 0. So these are pretty easy to do. You put 0 in for x, you find out that d is 0. Put 0 in the first derivative, and you find that c is 0. So c and d are both 0. So that means your original function and first derivative are these right here. Well, if you evaluate each of these two functions at L, when you put L into the original function, you get an output of h. When you put L in the derivative, then you get 0. So these two functions right here, these two equations are going to be our key. You notice that structurally they are very similar to one another. In fact, I'm going to take them up here, write them in blue. And what I'm going to do with this bottom function that was the derivative, I'm going to multiply both sides of this equation by the constant L. And what that will do is it will give me L cubed, L squared, but still 0. So now the two equations are AL cubed plus BL squared equals H, and 3AL cubed plus 2BL squared equals 0. Now it becomes a system of equations where, remember the X and Y system of equations, but now I have an A and a B, and I'm going to solve for A and solve for B using a cancellation method. So I'm going to multiply both sides of this top equation by a -3. That will turn the top equation into a -3AL cubed minus 3BL squared equals -3H. And that lines up perfectly to cancel out the A's, meaning that I'll end up here a -2BL squared and a positive -3BL squared and a positive 2BL squared ends up being the opposite of BL squared equals -3H. Dividing both sides by a -L squared gives me the 3H over L squared. That is what B equals. Similarly, go back to this original thing here. Instead of multiplying the top equation by a -3, I'm going to multiply by a -2. That allows the B's to cancel, and I can solve for A to give A is a -2H over L cubed. So taking the A, B, C, and D allows me to create the function as shown, and naturally the derivative is easy enough to figure out as well, either differentiating this, bringing the 3 down, bringing the 2 down, or substituting A and B into this first derivative right there. So that's the idea for this one. Stay tuned for the second one.